Today we're going to spend a little bit of time going over our chapter on basics of networking. We're going to go through a little slide presentation here that deals with networking, particularly in the context of the internet and how the internet utilizes an underlying protocol known as TCP/IP to get the work done. So let's start off with saying what exactly is TCP/IP. Well, fundamentally, it stands for Transmission Control Protocol, Internet Protocol. There are two different protocols there, and we'll talk about what each of those are. It was developed by the military back in the 60s, and it was used to connect universities and the Defense Department. Eventually, that grew into what we know today as the Internet. TCP/IP really defines the specific parameters of how devices connect to the internet and how they transmit the data back and forth between them. We're going to talk about three protocols. There's TCP, there's IP, and there's UDP. The distinction that we want to develop here is the idea of a connection-oriented protocol and a connection-less protocol. Now, TCP is a connection-oriented protocol. Its primary function is to provide reliable communication between applications. Note the emphasis upon the word applications. Now, the reason that it's reliable is because it offers error correction. So when you're using TCP, you have a guaranteed delivery mechanism in place. That is primarily due to something we call flow control, which determines when data needs to start and stop and when it has to be reset if it doesn't actually arrive. The other more simpler protocol, which is UDP, is known as a connection-less protocol. We don't ever use it to send important data because it's more or less a fire and forget kind of a protocol. You send the information out and it may or may not get there. It may not get there in the same order that it got sent out, but it'll get there fast. And that's why they use it for streaming applications, because it's much more insensitive to delays. IP is used, as I said, as communication between computers. So TCP/IP is used to communicate between applications. But IP is the underlying protocol that the computers use to talk back and forth. One of the things that you can note here is that IP doesn't tie up a communication line between two computers like in a circuit switch type of an environment, like a phone call. On a phone call, both parties are completely tied up with the communication and nobody else can be involved in that. IP is not like that. That's why a web server can handle thousands of client requests simultaneously. It's because there is no connection established. The IP packets, if you will, are broken up by the IP mechanism and by the TCP mechanism, and they're sent between the computers back and forth. And IP is the part that's responsible for routing those packets to the destination. So when an IP packet is sent out from a computer, it arrives at an IP router, typically what you would call your default gateway. So it's that responsibility of the router to route that packet out to the correct destination. Usually it goes out and talks to a whole bunch of other routers before it actually gets to its destination. One thing to note too, the path that the packet might follow could be totally different from other packets in the same communication. The internet is very good about managing congestion so that if things get all tied up between two locations, the packets, the routers, they'll know to route around that. So TCP/IP is just two protocols, TCP and IP, that are working together. Remember that the TCP is the application part of the process, like between your browser and a web server, whereas IP takes care of the communication between the two computers at a lower level. So where exactly does TCP/IP live? Well, it lives within the transport layer of the OSI model. Now we're not really going to get into the depths of the OSI model here, but you can see from the diagram that the 7-layer OSI model on the left, TCP/IP breaks that down into 4 areas. You can see that on the transport layer over to the right is where the TCP and UDP protocols operate. Above that in the application layer are the other protocols which we'll talk about momentarily. So the transport layer being responsible for the end-to-end validity and integrity of the transmission. This is a nice little video on how TCP/IP works. I think it'll start to pull together some of the things we've been talking about here. We'll, come on, get in there. There we go. This is actually dated back in the late 90s. Visualization. An idea what's going on at the network level.
For the first time in history, people and machinery are working together, realizing a dream. A uniting force that knows no geographical boundaries without regard to race, creed, or color. A new era where communication truly brings people together. This is the dawn of the net. Want to know how it works? Click here to begin your journey into the net. Now, exactly what happened when you clicked on that link? You started a flow of information. This information travels down into your own personal mailroom, where Mr. IP packages it, labels it, and sends it on its way. Each packet is limited in its size. The mailroom must decide how to divide the information and how to package it. Now, the package needs a label containing important information, such as sender's address, receiver's address, and the type of packet it is. Because this particular packet is going out onto the internet, it also gets an address for the proxy server, which has a special function, as we'll see later. The packet is now launched onto your local area network, or LAN. This network is used to connect all the local computers, routers, printers, etc. for information exchange within the physical walls of the building. The LAN is a pretty uncontrolled place, and unfortunately, accidents can happen. The highway of the LAN is packed with all types of information. These are IP packets, Novell packets, Apple Talk packets. They're going against traffic, as usual. The local router reads the address and, if necessary, lifts the packet onto another network. The router. a symbol of control in a seemingly disorganized world.
Whoops, sorry about that. Oh, let's go with this one here, this one here. Oh, this one's here, this one goes here. I don't like this one. Let's go with this one. Let's go here. This left. Let's go with this one here. Another channel here. Let's put that one here. Another one there. Let's put that one here.
There he is, systematic, uncaring, methodical, conservative, and sometimes not quite up to speed.
Oops, sorry.
But at least he is exact, for the most part.
That's that one goes there. That was there. That one goes there. That one goes there. And this one goes there. Oh, another one goes there. That goes there. He's behind him. Let's go there. That goes there. He goes there. Oh, let's put that one there.
As the packets leave the router, they make their way into the corporate intranet and head for the router switch. A bit more efficient than the router switch plays fast and loose with IP packets, deftly routing them along their way. A digital pinball wizard, if you will.
Here we go. Here comes another one. And it's another. Watch this, Mom. Here goes. Whoop, around the back. Hey, in there, in there, in there. Over to the left, over to the right, over to the left, over to the right. You got it. Here it comes. Right on. He shoots. He scores. It's going. Hey, wait. Here, watch out. Here comes another one. Oh, here we go. And it's gone.
As packets arrive at their destination, they're picked up by the network interface, ready to be sent to the next level. In this case, the proxy. The proxy is used by many companies as sort of a middleman in order to lessen the load on their internet connection, and for security reasons as well. As you can see, the packets are all of various sizes, depending upon their content. The proxy opens the packet and looks for the web address, or URL. Depending upon whether the address is acceptable, the packet is sent on to the internet. There are, however, some addresses which do not meet with the approval of the proxy, that is to say, corporate or management guidelines. These are summarily dealt with. We'll have none of that. For those who make it, it's on the road again. Next up, the firewall. The corporate firewall serves two purposes. It prevents some rather nasty things from the internet from coming into the intranet, and it can also prevent sensitive corporate information from being sent out onto the internet. Once through the firewall, a router picks up the packet and places it onto a much narrower road, or bandwidth, as we say. Obviously, the road is not broad enough to take them all. Now you might wonder what happens to all those packets which don't make it along the way. Well, when Mr. IP doesn't receive an acknowledgement that a packet has been received in due time, he simply sends a replacement packet. We are now ready to enter the world of the Internet. A spider web of interconnected networks which span our entire globe. Here, routers and switches establish links between networks. Now, the net is an entirely different environment than you'll find within the protected walls of your LAN. Out here, it's the Wild West. Plenty of space, plenty of opportunities, plenty of things to explore and places to go. Thanks to very little control and regulation, new ideas find fertile soil to push the envelope of their possibilities. But because of this freedom, certain dangers also lurk. You'll never know when you'll meet the dreaded ping of death. A special version of a normal request ping, which some idiot thought up to mess up unsuspecting hosts. The paths our packets take may be via satellite, telephone lines, wireless, or even transoceanic cable. They don't always take the fastest or shortest routes possible, but they will get there. Eventually. Maybe that's why it's sometimes called the worldwide wait. But when everything is working smoothly, you can circumvent the globe 5 times over at the drop of a hat. Literally. And all for the cost of a local call or less. Near the end of our destination, we'll find another firewall. Depending upon your perspective as a data packet, the firewall could be a bastion of security or a dreaded adversary. It all depends on which side you're on and what your intentions are. The firewall is designed to let in only those packets that meet its criteria. This firewall is operating on ports 80 and 25. All attempts to enter through other ports are closed for business. Port 25 is used for mail packets, while Port 80 is the entrance for packets from the Internet to the web server. Inside the firewall, packets are screened more thoroughly. Some packets make it easily through customs, while others look just a bit dubious. Now, the firewall officer is not easily fooled, such as when this ping of death packet tries to disguise itself as a normal ping packet.
It's okay, Gorm. It's okay. No problem. Have a nice day. We out of here. Bye.
For those packets lucky enough to make it this far, the journey is almost over. It's just a line up on the interface to be taken up into the web server. Nowadays, a web server can run on many things, from a mainframe to a webcam to the computer on your desk. Or why not your refrigerator? With a proper setup, you can find out if you have the makings for chicken cacciatore or if you have to go shopping. Remember, this is the dawn of the net. Almost anything's possible. One by one, the packets are received, opened, and unpacked. The information they contain, that is, your request for information, is sent on to the web server application. The packet itself is recycled, ready to be used again, and filled with your requested information. Addressed and sent out on its way back to you. Back past the firewall, routers, and on through to the Internet. Back through your corporate firewall. And onto your interface. Ready to supply your web browser with the information you requested. That is, this film. Pleased with their efforts and trusting in a better world, our trusty data packets ride off blissfully into the sunset of another day, knowing fully they have served their masters well. Now, isn't that a happy ending?
Well, I hope you enjoyed that. I thought it was a good little movie. It does an excellent job of portraying how some of the lower level operations actually come together and the things that happen to the packets as they travel along through the Internet and have to deal with things like the firewall. The firewall was one of those better visualizations that I've seen where it's sometimes hard to convey a good image to people of what a firewall does and how it processes packets of information based on the port address that they've been sent to. So in that particular video, we saw a firewall that was accepting traffic on ports 80, which is HTTP, and on 25, which is SMTP, which is your email. So other things were just not getting through, and that's fundamentally how that works. There are actually thousands and thousands of ports that are possible that can be opened up on a firewall, but usually there are only a few. So while we're talking about protocols here, let's move on. And we're going to look at a few of the ones that are out there. There are actually many. But a protocol is like a language, really, that the computers use to talk to each other. And just like in the real world, when you walk up to someone and have a conversation, if you're not talking the same language, things aren't going to go too well. And there's also certain protocols that we need to observe. For instance, you cannot both talk at the same time. That doesn't work too well. We generally open a conversation with a standard greeting such as hello or hi. There's certain levels of acknowledgement that go on in a conversation where whether it's nodding your head or saying yes or okay or responding. So acknowledgements and those types of things also happen with the protocols that are under TCP/IP. Let's take a look at a few examples here. One of the most common things you'll be using is HTTP, the Hypertext Transfer Protocol. That's what you use with your web browser to talk to a web server, and that is, as the little video pointed out, traffic that typically goes out through port 80, and the messages come back. Now they did talk about a proxy server in there, which is something that's not talked about here in the text, but the proxy server is an idea where it minimizes the utilization of the IP addresses, the real IP addresses on the internet. If every company that had hundreds of computers in their internal network had to have real IP addresses, we would have run out of IP addresses a long time ago. So they solved that problem by creating a proxy server that lets you utilize non-internet IP, non-routable IP addresses internally, and then the proxy server handles that traffic back and forth. There's another protocol called ICMP. ICMP are typically used for diagnostic purposes, or kind of an error messaging system within TCP/IP. But we utilize two particularly useful utilities that use ICMP. One of those is ping. Ping checks whether there is an actual host alive and whether it's reachable out there on the internet. These are done with ICMP echo request and echo reply packets. And then trace route is what we use to identify how many hops that the connection takes to the distant end, and it also measures the number of milliseconds for each of those hops. And we'll do a little practical homework exercise on that. There's an extension of HTTP known as HTTPS, which is the secure version of that. Always remember that HTTP, the basic HTTP protocol, sends information in clear text. So anyone with a wire sniffer or a wireless sniffer can see text and data that is transmitted in the clear. That's why financial institutions use HTTPS, which is the secure version of that, and that's where all of your communication is encrypted, and the verification, the identity of the server, is also part of that whole transaction. And there's the old file transfer protocol. Same delineation goes here. There's FTP and there's SFTP, where FTP transfers data in clear text, and its more secure brother, SFTP, encrypts the transmission between the computers. And we're going to use an SFTP client, although often these days it's more commonly known as SCP, Secure Copy, which is a similar protocol. We're going to use that as we transfer our files up to the web server when we get into the HTML programming and section here in Chapter 4. So you're going to see more about this. The hardware and the software that supports the entire TCP/IP mechanism, well, there's a lot of it. The graphic here is only meant to just give you an idea of the many different types and layers on the internet, whether it's residential or business or mobile, and how things flow through the network through edge devices, and they get aggregated at higher levels where the internet service providers pass information back and forth. Access can be through cable networks like Charter, DSL networks like your phone company, and the mobile networks like Verizon and those types of things. So there's a whole broad, wide world of networking out there. And of course, some of the software mechanisms like Skype and your browsers and Gmail. I mean, there's just obviously a tremendous number of applications that utilize the internet, and TCP/IP is the mechanism that passes it all along. We're going to get into TCP/IP addressing. The first thing that you need to take away from this is that an IP address is uniquely identifying a specific host on the network. Now, it is a 32-bit number. That means that each byte, which is composed of 8 bits, so there's a total of 4 bytes, 4 times 8, and each of those bytes can contain potentially 256 different values, starting at 0 and 1 and 2 and 3, counting in binary, all the way up to 255. And that should give you a little bit of an idea why a TCP/IP address is always 4 numbers, and it's always between 0 and 255. Another distinction is that they have to be unique IP addresses. You cannot share an IP address. The numbers are always, like I said, between 0 and 255. And even though they're written and separated by a period, when we're discussing IP addresses, talking about them, we always say dot rather than period. So the address shown up there would be 95.144.68.38. That's how we would talk about an IP address. And then as we get into the second part of this chapter, we're going to talk more about domain names. For now, we'll just mention that it's a lot easier to remember a name than it is some 12-digit number. And so there's an entire naming mechanism that operates within the internet world, and we'll talk about that. But when you access a website like the umt.edu, that name gets translated to a number, the IP address, by something called a domain name server, or DNS. And all over the world there are DNS servers that are connected to the internet, and they are the ones that are responsible for translating google.com or whatever it is that you type into your browser into the actual IP address that gets passed on to the TCP/IP protocol. And those DNS servers all over the world get updated with any new information, and it happens on a nightly basis. Let's talk just for a minute about email and the protocols that are used in email. There's a number of them. The first one that you would want to be familiar with is something called SMTP, or Simple Mail Transfer Protocol. The important thing to understand about SMTP is that it's used to send email. It's what you use to transmit email, whether it's from your client to the email server or email server to email server. So SMTP can only transmit pure text, not binary data. And so any binary data, any images or files that you attach have to be encoded by the MIME protocol. It gets converted to binary data. The POP protocol, Post Office Protocol, very commonly used to download your mail from a mail server. And the other one is called IMAP, Internet Message Access Protocol. The IMAP protocol, the main difference here between it and the POP protocol is that the IMAP protocol doesn't download necessarily your emails onto the device that you're reading the email from. So it's very handy if you're in a mobile scenario and you want to be able to just look at the messages that are on your email server without downloading them. Most of the time the POP protocol gets set up, it usually downloads the messages to your client and deletes them off the server. So with the IMAP, you can stay connected to the mail server and it doesn't delete them off of there. And that'll wrap it up for this slide presentation.